To solve a system of equations using the elimination method, you need to do what it says, eliminate. That means that you want to cancel one of your variables out. In this first example, that's going to be pretty easy to do because those y's, one's a positive and one's a negative, and they're already going to cancel each other out. So then you take each equation at face value, so that's a positive 5 and a positive 7. That gives us 12x. Those y's are going to cancel, equals 24. Divide by 12, and x is equal to 2. Once you get the first answer, then you're going to take that answer and go plug it back into one of the original equations, right there or right there. It's your choice. You'll get the same answer either way. I'm going to go to that top equation. So I'll say 5 times 2 plus y is equal to 6. So 10 plus y is equal to 6. Subtract your 10 over, and y is equal to negative 4. Now, some teachers like you to write that as an ordered pair, x, comma, y. Remember that every ordered pair, your x coordinate comes first and your y coordinate comes second. All right, let's take a look at this second example. So here, I want to cancel out some of the variables. Those x's look like they would be the most simple. Right now, they're both positive 4x. So what I need to do is make one of them be a negative. Then I would have a positive 4 and a negative 4, and they would cancel out. So I'm going to take that negative 1 and distribute it all the way through that equation, giving me negative 4x, positive 5y equals positive 13. This second equation, you just copy that over just like it is. And then we can see that our x's are going to eliminate. You have a positive and a negative. At face value, that's 8y is equal to 40. Divide by 8, and y is equal to 5. And as in the last example, when you get that answer, you're going to go back to one of the original problems, let him go live in one of those houses. I'm going to go to the bottom equation. I just think the numbers are a little nicer there. So 4x plus 3, but where that y is, I'm going to put a 5, is equal to 27. That gives me 4x plus 15 is equal to 27. Subtract your 15 over. 4x is equal to 12, and then divide by your 4. X equals 3. Again, if you need to write that as an ordered pair, write it as 3, 5, remembering that your x variable and then your y variable. Okay, let's take a look at example 3. In example 3, I'm going to also eliminate those x's. Now, right now, this is a positive 4. I'm going to need a negative 4 in order for those to eliminate. So I'm going to copy the top equation just like it is, so bring it over identical. This bottom equation, you're going to take that negative and distribute it through to every person. So that's negative 4x, negative 20y, and a positive 36. The x's cancel, and so I get negative 17y is equal to 34. Divide by negative 17, y is equal to negative 2. Now take that negative 2 and go plug him into one of his houses up there. I'm going to go to the bottom equation. So if I go to the bottom equation, that'll give me x plus 5, but where that y is, put a negative 2 is equal to negative 9. So then I have x minus 10 is equal to negative 9. Add your 10 to both sides, and x is equal to positive 1. So that would give me the ordered pair 1, negative 2. Okay, let's take a look at the next one. In example 4, I want to eliminate one of those variables. And so here's what we need to do. We need to choose the x's or the y's. It does not matter which. I do notice that I have a positive and a negative, so my signs are good, but those numbers don't cancel out. So here's something you can do every time if you want to. I call it the flip-flop method. If there is a 3 up here, put a 3 down there. If there's a 4 down there, put a 4 up top. If you do that and you flip-flop those every time, you'll always have the same two things, 4 times 3, 3 times 4, which means they'll cancel. Again, making sure that you have a positive and a negative, which we said we already did from the beginning. So take your 4 and distribute it through the top. We're going to take the 3 and distribute it through the bottom. And so when I do, that gives me 12x minus 24y is equal to 36. In the bottom equation, we have negative 12x plus 21y is equal to negative 48. The x's cancel just like we wanted them to. Then that's a negative 24 and a positive 21 to give me negative 3 is equal to negative 12. Divide by your negative 3 and y equals positive 4. Let him go live in one of his houses up there, so he could go there or he could go there. Again, it's your preference. I think I'll go to the top one this time. So if I go to that top equation, I'll have 3x minus 6, but where the y is, I'll put in the 4 that I just solved for. So that gives me 3x minus 24 is equal to 9. Add your 24 over. That gives me 3x equals 33. Divide by 3 and x is equal to 11. Giving me this for my ordered pair. Now, I wrote example 4 again because I wanted to show you another option. In this particular example, the one I did first, we eliminated the x's. So we did the flip-flop on the 4 and the 3. But what if I'd wanted to eliminate my y's instead? If I had wanted to eliminate the y's, I would have first of all seen again that I have the negative and I have the positive. So my signs are good for eliminating or canceling, but my numbers aren't yet. So we could do the flip-flop again. If this is a 6 in the top equation, bring a 6 to the bottom equation. If that's a 7 in the bottom equation, bring a 7 to the top equation. Because then you have 7 times 6 and 6 times 7 with a positive and a negative, and they will cancel. So I'm going to distribute my 7 through the top. That gives me 21x minus 42y is equal to 63. In the bottom equation, that's going to be negative 24x, positive 42y, and then 16 or negative 16 times 6 is going to give me a negative 96. Those cancel, and I get negative 3x is equal to negative 33. Divide by negative 3, and x is still equal to positive 11. So do you see that you get the same answers either way? You would finish that problem up just like we do all our problems. You would take that 11 and go place it in one of those two spots. All right, let's take a look at example 5. In example 5, we're going to choose a variable to eliminate. I believe I'll eliminate those x's out front. So I can do the flip-flop method again if I want to. If there's a 3 here, put a 3 here. If there's a 2 down there, put a 2 up there. That way I know that 2 times 3 is 6 and 3 times 2 is 6, and they will cancel if I make one a good guy and one a bad guy. You got to have a positive and you got to have a negative in order for things to cancel. So let's just put a negative on the top one. You could have done the bottom. It doesn't matter if you'd put it down there in that equation. All right, let's distribute there. Distribute there. And so this is going to give me in the top equation negative 6x minus 14y is equal to 2. Bottom equation, positive 6x plus 9y is equal to 18. The x's eliminate, and that gives me negative 5y is equal to 20. Divide by your negative 5, and y is equal to negative 4. Then we're going to take that negative 4 and go place it into one of those y variable spots. I'm going to go to the bottom equation. So when I go to the bottom equation, I'll have 2x plus 3, but where the y is, I'm going to put what I just got when I solved for y, which was negative 4. So 2x minus 12 is equal to 6. Add that 12 over. And 2x is equal to 18. Divide by 2, x is equal to 9. Giving me the ordered pair, 9, negative 4, we said, if your teacher likes it that way, with the x coordinate first and the y coordinate second. All right, there are other options on this one, so I wrote it again, just in case you wanted to go a different route. If I did not want to eliminate the x's, I could have chosen those y's. So if I had done that, I would say that I have a positive 7 in the top equation, so I'll make that be a 7 in the bottom equation. I have a 3 in the bottom, so I'll put a 3 up in that top equation. Again, nobody's going to cancel unless one is positive and one is negative. So put a negative on either one, the one that makes you the happiest, and then I'm going to distribute through to every one. And so that'll be negative 9x minus 21y is equal to 3. Bottom equation, 14x plus 21y is equal to 42. Those y's canceled this time because we chose those. And we have 5x is equal to 45, dividing by 5, and x equals 9. And we can see it's the same 9 that we got before. What we would do from this point is what we've always been doing. Take that x equals 9 and let him go live in one of those houses up there, and you'll get the same y answer from before. All right, let's take a look at example 6. In example 6, choose a variable to eliminate. It is your choice. I kind of feel like I might go for those y's simply because of the negative and the positive. So I won't have to mess with any signs because my signs are already there for me. So if I eliminate the y's, if I got a 5 in the top equation, I'll put a 5 in the bottom equation. If I have a 2 in the bottom equation, I'll put a 2 up there to the top. That way, I know I'm going to have 2 times 5 to be a 10 and 5 times 2 to be a 10 with a negative and a positive, so they'll eliminate. So let's distribute that 2 through the top, and that gives us 8x minus 10y is equal to negative 30. In the bottom equation, we need to distribute our 5 through, so that'll be 30x plus 10y is equal to 5 times 44 is 220. The y's are out of there, and so at face value, that's a positive 8 and a positive 30, which is 38. Here at face value, that's a negative 30 and a positive 220, which is 190. Divide by 38 to each side. And when I do that, I'm going to get x is equal to 5. All right, let him go back up there into one of those houses. And so you can choose the one you want. I think I will go to the top to substitute back in. And so when I substitute that 5 back up in there for x, that'll be 4 times 5 minus 5y equals negative 15. That'll be 20 minus 5y equals negative 15. Subtract that 20. So negative 5y is equal to negative 35. Divide by negative. And so y is positive 7. Writing that as an ordered pair should you choose to do it that way. All right, I want to look at some more options. I chose the y's that time, maybe because I thought the numbers might be a little smaller, also pretty much because I had the positive and the negative. But some students like to eliminate the x's. They like to do that because they're out front. They just feel like they'll make less careful mistakes, and that's certainly a fine thing to do. If that's the case, I'm going to take the 6 in the bottom equation and bring it up, and the 4 in the top equation and bring that down, knowing that that means I'll be having 6 times 4 and 4 times 6, which is 24 on both cases. However, one's got to be a negative, so that would work. That would give me negative 24x plus 30y is equal to positive 90. And then I would have 24x plus 8y is equal to 176. And so those could eliminate. I would have 38y is equal to 266. And then if I divide on that, I'm going to get the same answer that I had before of y is equal to 7. So that's one option, but let's talk about another option. What if I didn't want to do the flip-flop method and do the 4 and the 6? Another thing that you can do is you can look at those two numbers and just ask yourself, what can I make 4 and 6? What's the smallest number they'll both go into? And I'm thinking, well, 4 and 6 both go into 12. So if I could make them both be a 12 and a negative 12, that would eliminate. So in order for this to be a 12, I'll multiply 3, because 3 times 4 is 12. For this to be a 12, I can say 2 times 6 is 12. And of course, you need to make one a negative. So that would give me a negative 12 and a positive 12. And that is certainly another option. I want to finish this video up by a couple special cases. These are some things that happen sometimes when you're solving a systems of equations. So let's look at the first one. All right, so I need to eliminate the x's or y's. It's your choice completely. I feel like I might go for those y's. So in the top equation, I have a negative 2. So I'm going to multiply the bottom equation by a positive 2. So the negative and positive will cancel. So I'm going to bring the 6x minus 2y is equal to 5. We're just going to bring that over. Distribute that 2 through. That gives me negative 6x plus 2y is equal to 14. The x's eliminate. The y's eliminate. Those are the ones I wanted to, but they both did. That leaves me with nothing, like 0 over there. On this side, 5 plus 14 is 19. Well, 0 does not equal 19. That is a false statement. When you get a false statement, that means there is no solution to those equations. The answer is not false. I know sometimes you might think that because you're used to taking true and false tests, but the answer is no solution because you got a false statement. All right, what about this next one? So on example 8, let's eliminate a variable. I'm going to eliminate the x's. If that's a negative 3, then I need to multiply this by a positive 3. So distribute that through. And when I do, that's going to be 3x minus 21y is equal to 18. Negative 3x plus 21y is equal to negative 18. So I tried to eliminate the x's, which I was successful, but again, the y's eliminated as well. So I have nothing left over there. But in this particular special case, these guys also eliminated. So I have 0 equals 0. That is a true statement. When you get a true statement like that, it means there are infinitely many solutions. Infinitely many solutions. Not true. The answer is infinitely many solutions because we got a true statement. What that basically means is that these are the same two equations, just versions of each other. So every solution of one is the same solution as the other, and you just have infinitely many solutions. If you need more practice on solving systems of equations by the elimination method, be sure to watch my practice worksheet on this topic. There you can watch me work more examples. You can also pause the video, try the problem on your own, and then start the video back to check your work and see how you did. If this video was helpful, please like and subscribe to my channel. Feel free to leave a comment as well and maybe share with a friend. All of these things will help me to continue to grow my channel so I can help build your math esteem one problem at a time. See you later.